How we describe the direction of the coil or the angle between the coil and the magnetic field is a little bit weird. Mathematically, it's a dot product that you're going to see in that vectors course when you get there. So it'll make a bit more sense when you've done dot product that it has to be a cosine. But in the meantime, I'm going to try and talk you through sort of a non-math way as to how we describe it. If we've got a bar magnet sort of orientated this way compared to a coil, the magnetic field lines off the bar magnet always point from north to south, so they'd be pointing to the left. When the coil is orientated this way, I don't know if that's a word, orientated. When the coil's this way, a lot of those field lines can pass into that coil, pass through it rather well. So this allows for the maximum value of magnetic field lines passing through the coil. If I were to turn something 90 degrees, maybe put the magnet over here, now there's still magnetic field lines, there's still a coil, but those magnetic field lines aren't passing through the area of the coil, they're kind of passing between the actual coils. This doesn't have a lot of effect. So we had a maximum when the orientation was this way, we had a minimum when the orientation was that way. We're going to describe the direction of the coil as the normal to the face of the coil. So when the coil's this way, we would describe its direction as pointing kind of along its axis, left or right. Let's say we say it's pointing to the right. When the magnet's here, the angle would be 180. The value of this magnetic field property would be at its maximum. When the magnet's down here, now the angle's 90. The value is 0 actually. When the magnet's over here, the angle between that vector to the coils and the magnetic field would be 0. The property's at a maximum again. When the magnet's over here, the angle is, we could call it 270. The value's at a minimum. So when we're quantifying this, our function has a maximum at 180 and 0, and has a 0 value at 90 and 270. If you think about it, that's related to the cosine function. Cosine has a maximum at 0 and 180, and zeros at 90 and 270. That's kind of a weird way, and I don't think I explained it very well. Another way to think about it is, imagine that this coil, instead of being a coil, was a solar panel. And the solar panel was kind of laying across the top of here, trying to catch some sunlight. If the solar panel was this way, kind of orientated that way across the front of that coil, if my magnet, instead of being a magnet and field lines coming out of it, if it was some sort of flashlight, and instead of field lines, it's light coming out of here, if I shine a flashlight sideways at a solar panel, it's not really going to collect a lot of energy. So when they're at 90 degrees to each other, not a lot of energy. But if I put my flashlight over here, then those light rays are hitting that solar panel directly. I'm going to get a lot of solar energy collected on that area. The property that we're getting to, I'm kind of jumping ahead. If you skip ahead in the note, it's called magnetic flux, F-L-U-X. I got to be careful how I pronounce that one. Flux is always a maximum when the bar magnet is sending its field lines directly into the area of the coil, not when it's sending it across the coil. So it's going to be a maximum when the angle is 0 or 180, as if the front was a solar panel and the light was shining directly on it. If you shine on a little bit of an angle, it gets a little bit less. By the time you get to 90, there's no real solar energy being collected on our solar panel because we're hitting it sideways. If it was two-sided, we'd get a maximum again at 180. So I don't know if this is going to help much. I'll see email if you've got questions. But what's weird is when the magnet's orientated, there's my favorite word again, when the magnet's this way, that's when we're going to say that the effect is at a maximum. It's going to go with a cosine of the angle, and this sort of situation represents a cosine of 0 or a cosine of 180. This sort of situation would represent a cosine of 90 or a cosine of 270. It's a little bit weird. Bear with me, email if you've got questions. But as we work through the document, I think by the time we get to the end, it'll make more sense.